Today we're going to talk about transformations of trigonometric functions. So a transformation allows you to move the graph up, down, left, right, to make it big, to make it small. It's going to change the period. So you have the ability to stretch a graph wide, shrink it down. So all the transformations, we're focusing primarily today on sine and cosine functions. The transformations work for tangent, but we're not going to graph tangent. So we're focusing on these two functions today. Notice each of them contain an a value. Each of them contain the b value that we studied the other day. Now we're going to introduce an h value and a k value. The h's and k's, they are the same h's and k's that you have seen multiple years through multiple different transformations. So from the last lesson, we learned that your A values tell you your amplitude, so how high or how low did it go. Your B value is not your period, but it plays a role in your period. So periods are 2 pi over B. H is going to represent your horizontal displacement, or your left and right movement. And K is going to represent your vertical displacement, or your up and down movement. Now, whenever I teach my students this, I talk about H being a liar. So in real life, some of you may or may not have an ex, like an ex-girlfriend, ex-boyfriend, ex-partner. And if you had a friend that started hanging out with your ex, like they were hanging out with you, but then they turned around and started hanging out with your ex, they can't be trusted. So they don't always tell, like, that you can't trust them. So in this event, H here looks like it could be a negative number, like it's supposed to move to the left, but it doesn't. It actually moves to the right. So it's kind of like opposite of what it looks like. Same scenario, the K, if you have an ex, let's say an ex-girlfriend or ex-boyfriend, notice that K is not hanging out with your ex. It is not wrapped up in each other's business. It ain't having nothing to do with X like H is. It's doing its own thing. It's far away from your ex. This is a true and loyal friend. So your K value is going to tell you the truth. So if it's positive, it's going to go up. If it's negative, it's going to go down. So like other functions, trig functions can be translated. Given the functions on the left, that would be those three. H represents your horizontal shift. So that's your shift left and right. And K represents your vertical shift. That's your up and down. Okay. Your up and downs are truth. So if they look negative, they go down. If they look positive, they go up. Horizontal is called your phase shift, or horizontal displacement. These are the liars. So anything that looks positive really moves to the left, and anything that looks negative really moves to the right. So what we're going to do is in the next four of kind of examples, we're just going to look at what happened. Did it move up, down, left, or right, or a combination of them? So in question number one, you have a 2. Notice that your 2 is not hanging out with your ex. If it was hanging out with your ex, it would have a group around it. Notice it's doing its own thing. It's living its own life. So this would represent your K value. And Ks are true and honest, which meant it really did move up 2 units. Look at the one right below it, number 3. Notice that you do have extra information tucked in here. But notice that there are a set of grouping symbols. So they be hanging out, they tight, right? So they have, you have this pi over 2, and it's hanging out with your ex. And again, anybody who hangs out with your ex, or if you had a friend who hangs out with your ex, all of a sudden they're no longer trusted. You can't trust them. So this one did not move to the right like it looks like. It actually went to the left pi over 2 units. Let's look at 2 and 4 because they go by pretty quick. Even though we're not responsible for graphing it, tangent still has a transformation. It is not hanging out with your ex. It's a standalone number, which means it represents your K. Ks are kind, so we really are moving down 1 unit. And if we look at number 4, notice that your pi is hanging out with your x. It's got its own little friend group and everything, which makes it a liar. Or, maybe the liar's really harsh, but it just can't be trusted. So where it looks like it's supposed to go in the negative direction, which is left, this one's really going to be moving to the right pi units. So our h's and k's tell us left and right. A tells us our amplitude. B kind of helps us with our period. And the last one is your k value. K values are also known as midlines. A midline is just the line in the middle of your graph, and it can be found at your k value. So for example, if I look at these two, my parent function is my original function. It has no h's, no k's, no nothing. And the middle of this graph is here at 0. And that midline is going to help us count amplitude. So amplitude goes from the top just to the midline. So if we're going to focus on the transformation, all of a sudden we now have a k value of 4. Well, if I look at this new sine graph or this new trig function, and I find the center of it or the middle of it, midline, I can tell that it went up 1, 2, 3, 4 units, or there's a distance of 4 spaces. So that's why we say our midline can be found using k, because it represents a vertical displacement. So we're going to put all of them together. I'm going to show you kind of how to graph it by hand, but also how to use Desmos. And we're only going to do number 5 on the front and like the first question on the back. And I'm going to have all the notes available on Canvas, but for the instruction, we're just going to do those two. So I think it's like 5 and 7. All right, let's look at 5. I'm going to highlight all the things. Okay, we have an A value, and B values are found here. H values are found here. K values are found at the back. So if I kind of put together the last 2 days worth of material, my amplitude is 3/2. I do notice that my B value is an invisible number 1. So my period is 2 pi over B. And in this case, my B value is 1. So my period is just 2 pi, which means it's going to take 2 pi units to complete one portion of this graph, or one cycle of this graph. I have no H. There's nothing hanging out here in the H position. So my graph did not shift left or right. I do have a K value. That means it went up 3, or that my new midline, I misspelled that. My new midline is at y is equal to 3. So I can use that information to create a graph. Now, a sine graph is what I refer to as a hill and a valley, because the graph looks like a hill. Oops. So it looks like one hill and one valley. Some people say it looks like a squished S. I say one hill and then one valley. Hill and valley, and it starts and ends at our midline. So I'm going to put a dashed line for my midline. So one hill and one valley. Oh, so the same information goes here. Okay, I have an amplitude. I have an amplitude of 3/2. I have a period of 2 pi. I do not have a phase shift. I had a vertical shift up 3, and that means I have a midline at 3. So when we graph it by hand, we're going to start with that midline. Even if you're graphing it in delta math, you always want to start with your midline. So my midline is at y is equal to 3. This is where my graph is going to oscillate or move up and down from. It is a hill and a valley, so it's going to start here And my period is 2 pi, meaning that to create one hill and one valley, you will have to have 2 pi space, like the space there. I do know I have a hill followed by a valley. So it's going to turn from a hill into a valley somewhere in the middle. So here's the space for my hill. Here's the space for my valley. My amplitude tells me how high up it went. So it went 3/2 units, or this is also 1.5. So I'm going to go 1.5 units up. That's where I'll find my max. And I'll go 1.5 units down. This is where I find my minimum. So if I was to graph a hill, the highest point on a hill is in the middle. So here's the top of my hill. Here's the bottom of my valley. I have my 5 major points, and now I can connect the dots, and I can create my first cycle for sine. One hill, one valley. I do have a lot of dead space on my graph over here on the left, but because my function is periodic means it's going to repeat over and over and over and over and over. So I can come in here in my dead space and create another hill and another valley, and they'll end up connecting each other. So here's the top of my hill. Here's the bottom of my valley. And I can create a second hill, valley, and it goes right into the, let me redraw that. There's my hill. Here's my valley, and it connects right into the next hill and valley, hill and valley, hill and valley, hill and valley. If we're using Desmos, there's a couple things we can do. We can go, first off, I want you to go to the wrench, and we want to make sure we're in radian mode, so it should automatically be in radian mode. But here in your thing, oops, I hope I can take that out. Cut. We don't want a label, we want a step. Okay. A step is what you want it to count by. So here, in my step place, I notice that my graph on the paper counts by pi units. So 1 pi, 2 pi, 3 pi, 4 pi. You can put pi here. So you can use the pi symbol from your keyboard. Or if you're a typer, you can just type pi. It will automatically turn to a pi symbol. And that allows my x-axis to be counted just like it is here. Okay. So I can graph it. I can go y is equal to 3/2 sine, which is under your functions button, or you can just type sin. Sine, come on, sine of x plus 3. So here's my 0 to 2 pi. The middle of my graph is at y is equal to 3. So there's the center. I'm going to kind of put that as a dashed line. So there's the center of my graph. I can see that I have completed one hill, oops, and one valley. It's taken me 2 pi units to do so. My midline is at 3, so the middle is all at 3. Notice the y value is all at 3. My maximum is 1.5 units up, so 3 plus 1.5. My minimum is at 3 minus 1.5. And you get that beautiful hill and valley. And notice that if I was to zoom out, that pattern repeats continuously. And that's what makes it periodic. Hill, valley, hill, valley, hill, valley. And you can see each one of those hills and valleys are exactly 2 pi units wide, regardless of where we move it. So hill, valley, 4 pi to 6 pi. Let's look at the one on the back, number 7. So we get one sine graph, one cosine graph. Cosine graphs are what I call Texas Longhorns. So I grew up in Texas. So we had UT Austin, which was the Texas Longhorns. We also had real Longhorns, and they're very big. So we have a Texas Longhorn. So we still have the same information. We still have an A value, we still have a B value. This time we're introducing an H value, and we have a K value. A represents your amplitude. B is going to play a role in your period. So period is equal to 2 pi over B. And I noticed that I'm dividing by a fraction. So when you were in elementary school, we learned keep, change, flip allows us to divide by fractions. So you keep the first thing, 2 pi, change division to multiplication, and flip your fraction. So 3/2. This gives me 6 pi over 2, which is equal to just 3 pi. So from the left side to the right side of my Texas Longhorn will be 3 pi units. And now we're going to introduce for the first time our phase shift. Notice it's all grouped up with your x. It's hanging out with your x. It cannot be trusted. So instead of left, this went to the right, pi units. And then we had a vertical displacement. We went up 1 unit. So if I take that same information and fill out those key features on the right-hand side, my amplitude is 4 units. We calculated my period to be 3 pi units. I have a vertical shift or phase, a horizontal shift or phase shift to the right, pi units. I have a vertical shift up 1, which means that my new midline is at y is equal to 1. Okay, so let me get this zoomed in. Here we go. So I start by graphing my new midline. That kind of gives me where my function is going to oscillate or move around. My phase shift means that instead of starting here at the y-axis, I need to move to the right 1 pi units, and my graph will start here at pi. My period is 3 pi, so my entire longhorn has to be 3 pi units wide. If I try to move to the right, I do not have enough space, but I can move to the left. So we have 1 pi, 2 pi, 3 pi. There's my 3 pi units, or my period. And now my Texas Longhorn needs to fit within that space. So we can start, again, Texas Longhorn, shoop. Here's the middle of the graph. So here's your midline. So this time my graph starts at the horn on the Texas Longhorn, and that is amplitude of 4. So I'm going to start here, and I'm going to start where my horn is. So 1, 2, 3, 4, way up here. So from horn to horn, it's 3 pi units. Well, his little chinny chin is in the middle of his horns. So we come over here. I'm not trying to be fancy, so I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces between horn and horn. So halfway is 6. 4, 5, 6. 1, 2, 3, 4. So here is his chin. Okay. So we have the 2 horns and we have his chinny chin. We need to figure out where his ears are. So I know the distance between here and here is 6. So 1, 2, 3. Here is an ear. And here's his second ear. You've got all 5 points. So you can now come in here and, ooh, a little bit too much. And draw that Texas Longhorn. So for people who need to see it, here's, the cow's ears. They're not very big. Cow has kind of a big head. Cow's eyes lie somewhere about here. Here's his big old nose. Okay. And then those Texas Longhorns, they are very long, very sharp. And there's your Texas Longhorn. That's why we call it a Longhorn. If you have dead space in your graph, you can continue the pattern. So 1, 2, 3, oops, let me change my color. Here we go. And you can keep that pattern moving like so. And again, you can create the same graph using Desmos. So y is equal to 4 cosine. It's going to let me, no. 2/3 x minus pi plus 1. And it does not like the times symbol, so we'll take that out. There you go. Here's your Texas Longhorn. Here is your midline. There's, the middle of your graph. You can zoom in. You can see that the Texas Longhorn did not start at 0 where we typically have it starting. It did have to shift over to the right, pi units. So we have, there's one Longhorn, there's the other one, and you can see that it is 3 pi units wide, just like ours here. Okay, ours is just very spread out. You can see it's 3 pi units wide. You can see that it's got an amplitude of 4. Oops. Did I put it in there? I sure did not. There's the 4. There we go. So we have, your midline at 4. And then, you've got maximums. I'm sorry, your midline is at 1. My apologies. Your minimum is at -3 or 1 minus 4. Your maximum is at 5 or 1 plus 4. You've got your Longhorn all lined up. So you went from horn to horn. So you can count now from pi to 4 pi. That's 3 pi units. So you can see all of your stuffs. Okay. The same works for all sines, all cosines, and tangents. So the big idea is understanding that A is your amplitude, B plays a role for your period, H is a liar, but it moves the graph left and right, K is kind, it's also your midline. So putting all of those transformations together and then gleaning information from that. Okay, so that's it for the examples for the video, but the entire set of notes will be available for you in Canvas from all of the examples together.